Today we're talking about solving systems of equations. That means I have more than one equation and more than one variable. So we're trying to figure out which x and y values make both equations true. All right, and we've got two different ways we talked about substitution or elimination. So let's talk about substitution first, right? Substitution is when one of my variables, I can either isolate it or already is isolated. Well, this says y equals 2x minus 9. That means 2x minus 9 and y are the same thing. So I can substitute this in for y in my equation. So then all I have is x's, right? I can only solve for one variable at a time. So I'm going to rewrite this equation up here, 4x minus 3. But instead of 3y, I'm substituting in 2x minus 9 in place of y because they're equal. If they're equal, then they had the same value. So I can plug that in instead of y. Well, now I'm just going to solve this equation like we've been solving. All right, so I got to distribute. So negative 3 times 2x is minus 6x. Negative 3 times negative 9 is positive 27. So I gotta combine my like terms. 4x minus 6x is negative 2x. All right, so now both sides are simplified as possible. Well, all my variables are already on the left. So now I just gotta move my constant to the other side. Minus 27. I get negative 2x equals negative 10. And then our final step is, well, I gotta isolate my variable, so I divide by negative 2. X equals 5. So I know the x value of my solution is 5, right? So x is 5. So now I get my y value. I'm going to plug this back into our equation up here because y equals 2 times x minus 9. So y equals 2. But instead, now I know what x is. Instead of x, it's 2 times 5 minus 9. Well, 2 times 5 is 10. 10 minus 9 is 1. All right. So I can double check that. All right. 4 times x. So 4 times 5 is 20. Minus 3 times 1 is 3. 20 minus 3 is 17. Oh, yeah, that works. So again, if I want to substitute, we're plugging in this. One of our variables is already isolated, either y or x. I'm going to substitute in this entire thing in place of y. So I rewrite. Everything else is negative 3x plus 5. But instead of 5 times y, I'm substituting in 6x plus 15 equals 21. All right, well, now I'm going to solve this thing. Like, all right. So now we're solving our equation. Distribute. I get 30x plus 75 equals 21. So now I combine my like terms. Negative 3 and positive 30 make 27x plus 75 equals 21. So now I gotta isolate all my variables are already on the left. So I gotta move all my constants to the right. So I subtract 75. 21 minus 75 is negative 54. Divide by 27. X equals negative 2. So again, my x value is negative 2. So now I know what x is. I can plug that back in. So y equals 6. But instead of x, I know what x is. So 6 times negative 2 plus 15. Well, 6 times negative 2 is negative 12. Negative 12 plus 15 is positive 3. All right, so that's substitution. A lot of us are like, man, I don't like substitution. And me personally, I eliminate almost every time. All right, sometimes substitution, if it's already set up, well, I can do that, right? We know how to distribute and combine like terms and solve. That's easy. But for the most part, I like to eliminate. All right, and when I eliminate, I need to eliminate one of my variables because I can't solve for x and y at the same time. So like here, if this is positive 2x and x, I have positive y, negative 2y. Well, if this is negative 2y, if I want to make this eliminate, I need to make this positive 2. y. So I'm going to multiply this entire equation by 2. And I'm going to rewrite it under it. 4x 2 plus 2y, and 2 times 40 is 80. Because now, well, when I combine my equations, well, -2 and +2 equals 0. So they eliminated. That was the whole point. The same number, but opposite values. Well, x plus 4x is 5x. -20 plus 80 is 60. So I divide by our coefficient, and I get x equals 12. So I know the x value of my solution is 12. So now I got to plug 12 back into either one of our equations to solve for y. It doesn't matter each one. Let's do it to this one. So 2, but now I know what x is. 2 times 12 plus y equals 40. 2 times 12 is 24. If I'm trying to solve for y, I need to isolate y. So I'm going to subtract 24 from both sides. I get y equals 16. All right, so elimination is I need to eliminate one of my variables. I can only solve for one at a time. But down here, like, oh, remember, they gotta look the same. If this is x plus 6y equals -59, I gotta move this y over. So this is really x plus 2y equals 9, right? Because I had to move my y to the opposite side. If I move to the opposite, it becomes the opposite. So now I got to figure out what do I want to eliminate. I can eliminate either one, but if this is x and this is x, well, that means, well, they're already the same number. I just got to make one of them negatives. And I'm going to multiply this whole equation by -1, because then it's -x minus 2y equals -9. Because now my x is eliminate. X and -x eliminate. So now I have 6y minus 2y. Well, that's 4y. -59 and -9 make -68. So let me divide by our coefficient. Y equals -17. And we said y, so I got to make sure I put it. All right, y equals, my y value needs to go in the y spot. So now I know what y equals. I can plug it back in up here. X equals -2. But now I know what y is. So instead of -2y, it's -2 times -17 plus 9. Well, -2 times -17 is 34. 34 plus 9 is 43. 43. All right, guys. So to eliminate, all right, I got to have the same values but opposite signs. So I got to multiply at least one of my equations all by the same number. Then I get the opposite and they eliminate. Good luck, guys.